Till now, all the model which we have considered, all the equations which we have defined are with an assumption that internally inside my home or inside my building, there is no heat transfer, heat generation happening, or there is no internal heat gain to be as a term, as a very precise term, internal heat gain inside my building. But what if we have some internal heat gain? So what is the internal heat effect of internal heat gain on temperature? The temperature equation which we considered previously was UA delta T is equal to rho VC dt by dt. And there are no heat addition or heat removal any other kind except UA delta T. So this is the heat transfer happening from the surface. But if I have a body and there is some heat generation, Q internal or Q heat generation inside my building, this heat generation is for a building means electricity, electrical heat gain from occupants. These are the two factors from which the building can internally generate heat, or from appliances. Electrical means appliances or lights, everything included over there. So if there's internal heat generation happening, what the difference this would occur is, initially my temperature, let's say the outside is colder, my internal temperature was earlier, internally my temperature was Ti and it dropped down to T out. But now there is heat generation inside my building. So this T out can never be reached. Earlier the T out could be reached because there was no heat generation. But now my steady state temperature, the earlier steady state temperature was T out. But now my steady state temperature will be T out plus the internal heat generation divided by UA. So this is the extra thing. Now my temperature, so if my outside temperature was 30 and there is some internal heat gain of, let's say 5000, and my UA values is 250, then this will be 20. And earlier my building at the end, if we wait for infinite time, that's the steady state temperature, then at infinite time my temperature will be 30. So what the exponential equation which we have after solving this, we have the exponential equation, right, which had an exponential over there. So that exponential equation means if I start with a Ti and my outside temperature was T out, this will be an exponential drop to T out. And at time T is equal to infinite, my temperature will reach the outside temperature. But if I have a heat generation happening, this will not be a case. What will be the case now will be, my building starts at temperature Ti, my outside temperature is To, but there is an internal heat generation which is happening. The extra factor makes it like that. So if this is the extra contribution which is coming from heat generation. So even if at T is equal to infinite, my building will not reach T outside. It will only reach T outside plus this factor. So what's the effect now? My equation changes to this. So basically the effect is my outside temperature has changed to outside temperature plus this much. So this outside temperature doesn't change. This is still the same over there. It looks over there, but I'll let's say just we'll directly write down the final equation, so it becomes directly easier for you to understand also. So my final equation now will be T at some time T will be T out plus Q gen upon UA. This UA is UA total and that UA is not is from the walls, windows, and all those calculation, plus T initial minus T out plus Q gen upon UA total into exponential of minus UAT upon rho VC, right? This is the final equation which will give us the temperature of the building at some time T. If we had an outside temperature of this much, if there's an internal heat gain from electrical equipments, from lights or occupants of value of Q gen, my UA is building envelope UA value, initial temperature of Ti, outside temperature, and these are the repeated. UA is same after some time T, and rho VC are from the density, the volume of my building or the concrete which I am considering, and C is the specific heat capacity of my system. And again the Q, which is the total heat transfer which is happening, is given by rho VC T initial minus T out plus Q gen upon UA into 1 minus exponential of minus UAT upon rho VC. So the only change is everywhere wherever we see T out in our previous formula, we have replaced my T out with T out plus Q gen by UA. That's the only change. I hope you have understood the difference, and the effect of internal heat gain and is very important, because in all our buildings right now there is obviously and continuous internal heat gain from equipments, because lights are always on inside our buildings. So understanding the effect of internal heat gain is very important. Thank you.